Welcome to Jimbo's Garage.
Good afternoon, everyone, and welcome back to Jimbo's Garage. Well, in today's video, we're going to be making a light post for an outside kitchen barbecue area. We're going to be using this 4-inch square tube 250 wall for the post, and I've got some 1/8-inch aluminum plate, some 3/16 aluminum plate, 1/4-inch aluminum plate, and some 1/2-inch aluminum plate for the base plate. We're going to primarily be focusing on some aluminum MIG welding, aluminum TIG welding, and we're going to break out the HTP 875 SC hand plasma cutter and attempt to cut this 1/2-inch thick aluminum plate. I've never done anything this thick before. That's going to be fun. So let's get started on today's project. All right, so what I've got here is I've got a drawing that the owner provided me with. It's just a sketch, and this sketch is, kind of a rough idea. So basically, he's going to have a light that's going to mount to the top here, and this is kind of what the light's going to look like. This will be the post. This is the barbecue area with the countertop that kind of cantilevers over the top. We're going to put a peak top on it. And then this area right here is going to be more like this. I need a box out around this post, about an 8.5 by 5.5 box all the way around. That's what this is. The mounting plate is 5 by 8 that needs to go on there. He just wanted this to box all the way around. Down lower is where a base plate's going to be going, the 1/2-inch thick plate, and it's going to be anchored to this barbecue, which is solid concrete. And then I'll have a couple brackets coming off of here, be welded onto there. This is his drawing. I've kind of created a little bit better of a drawing, something a little bit better for me to go with some dimensions here that I need to go with. Again, the box, the peak, the light, this is the barbecue and the counter area. The base plate here is going to be anchored into the solid concrete wall. We're going to have some brackets coming off here that's going to be welded to the post itself for some additional support. This is going to be it shows a square here, but it's actually going to be just a round hole. He's going to mount an outlet to the surface here, and then wire is going to go up inside to a box that we're going to recess into the column here, and this is how he's going to get his power up there. This bottom half of the post is actually going to be mounted in some concrete down below right here that adds some additional support for this length. The total length of this from the bottom to the very top is about 100 inches. This is a better look of the light that he's going to be using on this. So hopefully this provides a little bit more detail for you guys. So let's get started on this. All right, so this is an all aluminum project right here. This is kind of fun for me. It's something that I just don't do all the time. Working with aluminum and doing some aluminum MIG welding, aluminum TIG welding is always a challenge for me, but it's always fun and a good learning experience. All right, so after cutting the post to length, this is some 1/2-inch aluminum plate, and I'm cutting a 12-inch by 12-inch section out, and I'm going to be using the 875 SC handheld plasma cutter for this, and we're going to see how well it does right here on this 1/2-inch aluminum. And you can see it is no problem at all going through there. A little user error right there. I got hung up on that, but I've got a straight edge. I'm just dragging it through, and it's cutting it no problem. Since I don't do this all the time, and running the camera and trying to do the work at the same time, sometimes you get little things, just little hiccups, and that's what I had right here. I couldn't figure out what the problem is here. I couldn't cut. I didn't know what was going on. Well, I didn't have my ground hooked up. Big difference. All right, once that got hooked up, you can see no issues at all. Cut through there pretty good. Left a little bit of dross, quite a bit of dross, I should say, on the outside there, but no problem. Grab my Mercer flap disc right here and load it up with some beeswax, and then just grind everything flat. That beeswax is a key if you're working with aluminum and you got a flap disc. If you didn't have that, your flap disc would load up immediately and it would just be a bad day. But with that beeswax on there, it cuts through that aluminum, no problem. All right, I'm over at the drill press here, and I'm drilling 4 holes in each side of this base plate or mounting plate. And these are 1/2 inch in diameter. I've got some screw anchors that I'm going to be using that we're going to be attaching it to the block wall, the concrete block wall. All right, this is just a 4-inch standoff tube, if you will. What I've got to do is I've got to weld this to the post, and it's going to be standing off the post is the post needs to be offset by 4 inches to get around the cantilevered countertop. Okay, let me show you what I got going on right here. I'm about ready to do the first part of the aluminum MIG, and I just kind of wanted to show you my setup right here. We've got the 1/2 inch thick 12-inch by 12-inch aluminum plate here, and I've got it clamped down with some fixture clamps to my welding table. The 4-inch square tube, and I've got it clamped down with these Bessie extended fixture clamps. I got these at weldtables.com, and you can see it extends right over, and I'm able to hold this securely in place with a block of wood pressing down here. I've got it centered on the plate. And for the machine, we're operating off of the HTP ProPulse 300. I've got it spooled with some 35 thousandths 4043. I'm using 100% argon at about 60 CFH. And we're going to be running about 547 inches a minute at 24.5 volts. We're going to give that a try and see if this is going to work. All right, so, aluminum MIG welding could be a little tricky. If you don't have your settings just right, it could be a bad day. Trust me, I've learned the hard way, and when they're right, and everything works good. And in that case, that's what's happening here today. I got the settings just right out of the chute, and everything seems to be working just fine. I found it works the best if you do a slight push with aluminum, and looks like we get the best results by doing a slight push angle. All right, now it's over to start creating the box, this 8.5 by 5.5 inch box. I'm using some 1/4 inch plate right here, and for cutting out all the pieces for that, I'm over on the bandsaw. The bandsaw works really good with aluminum. It's got a wood cutting blade on there, but when you're cutting aluminum, it cuts really well. And this is the best way for me to cut this. A lot of cutting going on. It's a smaller section, so cutting these plates out worked really well. It would have been a little bit more difficult with the big base plate. That was a 24-inch by 24-inch piece I started with, and so it would have been a little bit difficult on the table here for the bandsaw. But for the smaller stuff like this, it works really well. And then these are the peak pieces that I'll be using for the peak, and I'm just cutting them out, just getting all the cutting of all the material that I need right now on the bandsaw. We'll be putting those on a little bit later. All right, well, I'm starting to assemble this. Now, again, this is what I'm talking about, but I don't want to say being in a hurry or getting in a hurry, but mistakes happen. And it happens with everybody, and no matter what, who it is or what you're doing, everybody makes mistakes. You can't be perfect all the time, and you'll see that's the case here in just a minute. Trying to get everything just right, run the camera, think about everything being right there, and also thinking about the build and all that. Sometimes it just gets away from you. All right, just some holes right here to get my jigsaw in there to do the cutting. And surprisingly, again, I had a little bit of trouble with the jigsaw right here. You'd think cutting through aluminum would be, like it was on the bandsaw, pretty smooth, but it was a little bit of work. This took some time to get through here and get this cut out. I don't know if it was just going too fast. It definitely had a sharp blade on it. As a matter of fact, I changed the blade out to a new one during the middle of all this, and it's still the same results, but nevertheless. Okay, after hours of detail to get this thing cut out so this cutting box is going to fit in here nice and square, that worked out pretty good. It was then when I realized that there are 4 different sizes of these panels. I've got 5.5 by 8.5, and I've got 4.5 by 8.5. The 4.5 side goes on the side, the 8.5 goes on the face. This hole needed to be cut in the 8.5, not the 4.5. Extreme bummer. However, I went ahead and got it redone, but you learn your lessons from this. You see all the scratch marks around here? Now, even though this is going to go to powder coat, it's going to be sandblasted, primed, and powder coated. You're never going to see this, so I wasn't too worried about that. But on this one, I was able to put tape all the way around and eliminate all that surface scratching. So now, that was wasted. Another hour of detail here. This box fits right in there just the way it's supposed to. And I got my 8.5s, and then I just went ahead and cut another 4.5. So now I got my 4.5 by 8.5, my 5.5 by 8.5. Now we can start welding this thing together. All right, with all that out of the way, it's time to start assembling this this little box right here. And I'm just getting everything clamped down to the welding table with the fixture clamps. And then I'm going to go ahead and just tack this box together in case I've got to move things around a little bit. And once I get all the pieces on here and all tacked in, get everything all nice and square, and I know where it's at. That's what we're trying to accomplish right here. A little challenging getting inside, doing the tacks on the inside right here, but managed to get it done. You're not going to see that stuff on the inside. That's going to be inside the tube. All right, so I'm going to switch over to some TIG welding right now. A little bit more detailed work. This is a 1/2-inch piece of flat bar stock that needs to be welded all the way around the perimeter on both sides here. That way it's going to take up the room it needs to slide over that post. You know, I probably could have continued with the aluminum MIG, but it lays down a much heavier bead, and this is a little bit more detail work, and I just wanted to practice my TIG welding here. I thought this was just a little better of an application for this. You know, if you don't do aluminum TIG and MIG very often, which I don't, you know, maybe a handful of times during the year here in the shop, it's nice to just kind of keep your skill refined a little bit. And, you know, as long as you do it every once in a while, you know, I'm not the best by any means, but I can get the job done. And by practicing a lot like this, it helps out. For the settings on this right here, I'm operating off of the HTP 313 AC/DC TIG machine, and I'm at about 185 amps, and I have a 332nd tungsten with 332nd filler wire 4043, and I'm running about 25 CFH pure argon. That seems to work the best. Cup size is a number 6 on this. You know, I noticed that using a little bit smaller of a cup size seems to contain the argon and seems to work better for me. All right, well, I'm on a roll with the TIG. I may as well just keep going. I've got this long weld right here on both sides here, and I just want to keep rolling and just finish this up. You can see that little prop I've got there. That's a little mag block, yeah, with an adjustable tower on it. you know, it works really good for stuff like this. This box is about 6 inches off my table, and just by getting this thing adjusted and raised up a little bit, it gives me a nice platform to work with. Pretty handy to have. All right, just got these two sides left. All right, a little test fit, and that seems to work just fine. And now I just want to clean things up. All right, just fasten it right down here to the welding table and load up the flap disc with some beeswax, and went around and just kind of cleaned up all these welds all the way around, kind of rounded the edges, softened it up a little bit. That's the look I was looking for. You know, we just want to have a nice smooth finish on this. Give it that appearance anyway on this light post. Again, the beeswax, I know I mentioned this earlier, but that's really a key when you're working with aluminum. It's really a lifesaver, and it has no problems removing this aluminum. You know, I get a lot of people ask me what flap discs I use. I have all Mercer products, all Mercer abrasives. You know, I use all their stuff for abrasives, and I really have good success for that stuff. Works really well. I especially like the 60 grit. I've got all grits. I got 40, 36, 120, but 60 seems to be the go-to for me for most of the stuff that I do. It gives a pretty good finish and removes some metal pretty good. All right, with that all done, I just need to cut an opening here in the tube. And once again, I'm back with the plasma cutter, just using a straight edge right here. This hole right here just needs to be bigger. It's all going to be hidden inside, and it just needs to be bigger than what I've got going on with this right here, so that box can easily fit in there. Just like that, and just like that, that's what we're looking for. All right, everything positioned in, and it's time to just weld this box in. Now, my thinking was, you can see I welded on one side, I turned it over, I'm welding it on the other side. I just was worried about heat deflection or distortion, or this thing warping in one by putting too much heat in one side. So that's why I'm alternating back and forth. You know, don't know if it makes a difference, but that was my thinking anyway. If I just distribute the heat in different areas throughout this, hopefully that'll help reduce any kind of deflection that would occur. All right, so now it's the peak. There's another learning experience right here. You remember, I'm still at 550 inches a minute, and that ain't gonna work for what I'm doing right here, and you'll see. I've got these little triangle pieces that I've cut out, and I've just having to make a few adjustments to make them a bit better than what they did originally. I had to trim some off the sides in order to get these couple of pieces in. The idea is I just want to tack them into place, and then once I get them tacked into place, then I'm going to go ahead and you know, bend them around to where they fit. All right, here's the last piece. And now I'm ready to start piecing everything together. And it's right about here where I realized, wow, it ain't working here. I'm blowing holes in and things are just ugly. It's just getting crazy. And so I went and I turned it down. Still not enough. Still blowing holes in it. Turned it down again. Still no good. But by the time I figured it out, I got it down to where it was about 300 inches a minute. So from 500 inches a minute to 300 inches a minute, and I finally figured it out. But it's not going to be a problem because you can see I'm going to grind everything down right here and shape it all up. So if there's any low spots or holes, I'll get it all filled in. But that was a learning curve, you know, and that's what you do. This is how you learn. You'll see that as I'm cleaning this up, you'll see some low spots right here, and you'll see what I'm talking about. And there they are. So I'm just going to come back. I'm going to fill this all in. and then I'll be able to do the finish cleanup with the grinder here. Surprisingly, it's shaped up pretty good. You know, those points came together pretty good, and you know, it ended up looking not too bad. All right, you can see that everything did level out nicely. And now it's time to finish this up. Okay, well, I've made some progress here on the post. What we've got is I've got the peak that's now welded on and ground down. That turned out surprisingly well. I've got the 8.5 inch by 5.5 inch extended box welded on with the outlet access hole in it. And then I have went ahead and tacked the base plate to the bottom part of the post. Now, per the plan, there's a certain amount of dimensions that I needed to hit to be sure that all of these things are accurate. And I've double checked everything, and this is where I ended up. Most importantly is I'm perfectly level right here and level in this direction right here. Surprisingly, this aluminum post had a little bit of a twist in it, so I had to shim it up on this side here, but most importantly I wanted to have the base plate square to this part right here, as this section right here is what's going to be above ground and above grade, and that's the important thing. So with everything tacked in, the only thing I have left to do is to go ahead and weld this base plate to the bottom of the post. I've got a couple gussets I want to get on there, and then I need to drill an access hole in the side right here. They're going to put a surface mount outlet on there, and that's how they're going to gain access to run wires up the center of the post and out the outlet hole in the bottom of the extended box right here. So let's go ahead, weld this thing up, get the gussets on here, and finish up this project. So I'm going to go ahead and weld here on both sides of the post right here, but on the other side I'm going to leave that. I've got these gussets, or plates if you will. I guess they're not gussets, so they could be gussets, but they're plates, and you can see that that's what I'm going to do. I'm going to weld this on. So the reason why I'm doing this is you can see that 4-inch by 4-inch tube. It's kind of a standoff tube. I mentioned that earlier. To get it away from the barbecue, because the back of the barbecue has got a cantilever counter on it, and I need to be 4 inches back. So that put a lot of pressure on the post at that point right there. So this is why I wanted to put these additional gussets or plates or braces, if you will, to help relieve some of that stress. Front side, back side, everywhere I could, I just kind of welded that in. You got to remember also too that it's going to be bolted to the back with these plates on here, and then it's also going to be supported with a concrete base as well. So it's going to have plenty of rigidity, and it's not going to be a problem. So this is 1/4-inch plate, and you can see that I had to notch it around the weld at the top, so that created a big gap in there, almost 1/2 inch deep at the top where the base plate is. And you can see I'm just kind of welding this up right here. This is working out well. And to fill that, it took about 3 passes to fill that opening there. And then I ultimately put a cap across the top, which ended up being pretty fat. But nevertheless, you're never going to see it. It's all in the back, and it's going to serve its purpose. It's going to be plenty strong. All right, and that pretty much completes it. I did mention that I needed to drill a hole in there, and I did that off camera. I did it with an 1 1/8 hole saw, and got that drilled in. And this is, unfortunately, also I don't have any pictures of the install, but I think this is primarily a welding video with aluminum. So I hope you guys enjoyed watching all this. It was a fun project for me, and we'll see you guys on the next video.
See you next time on Jimbo's Garage.